All right, 4.2 part 2. Let's finish up these notes. So now we're the first two problems that were in these notes, the first two word problems, you are given information to give you 2 points essentially on the line. You're given x1, y1, x2, y2. Now this problem is going to be a little bit different. You're going to be given the slope instead. Instead of being given 2 points, you are given the slope. So let's read this problem and see how that looks. For the following exercises, consider this scenario. The weight of a newborn baby is 7.5 pounds. The baby gained half a pound each month for its first year. Okay, so hopefully just reading that, you can kind of see newborn, so that's the initial weight, newborn, so that is months equals 0. The baby weighs 7.5 pounds. So if you're thinking y equals mx plus b, then b would be 7.5 pounds. That's the initial weight. That's weight at x equals 0. The baby gained half a pound each month for its first year, gaining half a pound per month. So that will be the rate of change or the slope. 0.5 pounds per month is the rate of change. So that is m. So they gave us m and b in this scenario. Okay, let's see what a says. Find the linear function that models the baby's weight, w, as a function of the age of the baby in months, t. So they specified what variables they want us to use. W is weight, and then your months is going to be t as in time. That's t is very commonly used as a variable when you're talking about time. Okay, so w of t, the weight in terms of the time, the number of months, is going to be 0.5, because that was our slope, that's our rate of change, t plus 7.5. So just using that y equals mx plus b model to write the linear function there. When did the baby weigh 10.4 pounds? Okay, so let's plug 10.4 in for w, the weight, and solve for t. This problem's actually a little bit easier than the ones we did yesterday, in my opinion. So 10.4 minus 7.5, and then we're going to have to divide by the slope, 0.5, to get 5.8. So t comes out to 5.8. Subtracted 7.5 and divided by 0.5. So that is months. So at about 5.8 months, the baby weighs 10.4 pounds. Now C. What is the output when the input is 9.2? If the input is 9.2, then they're saying 9.2 months, right? Because our input is t, and t is in months. So we're doing w of 9.2, and we're going to see what the output is. That's going to tell us how much the baby weighs. Oops. Plug in 9.2 here. So 0.5 times 9.2 plus 7.5. Okay, so the output there is 12.1. So think about it. After 9 months, the baby is weighing in at about 12.1 pounds. That is what that means. So I can add units there because I know weight. The weight is being measured in pounds. All right, let's look at our last problem. This is going to be like a geometry problem. We're going to be using a diagram to model this scenario. Find the area of a parallelogram. So remember, a parallelogram is a shape that has all four parallel sides bounded by the, so your parallelogram is going to be bounded by the x-axis, the line g of x equals 2, the line f of x equals 3x, and the line parallel to f of x passing through 6, 1. And that line will be called h of x. All right, so it says find the linear function for h of x. Well, this is what they told us about h of x. They said it's parallel to f of x. Well, parallel means they have the same slope. So the slope of f of x is 3, so the slope of h of x is 3. Okay, and then we don't know what the y-intercept is, but we do know that it passes through 6, 1. So what you could do is plug in that 0.61 for h and for x. So that would be 1 for h, the output, and 6 for x. And then you can solve for b. So 1 minus 18 is negative 17. So the y-intercept there should be negative 17. So h of x equals 3x minus 17. All right, part B. Identify the x-intercepts of f of x and h of x. So for f of x equals 3x. And x-intercept is where y equals 0. Think about it, your x-axis, the y value there is 0. So I'm going to plug in 0 and see what x should be. Well, if I divide by 3 there, 0 divided by 3 is 0, so x equals 0. So the x-intercept for f of x is at 0. Now let's do h of x. h of x is our 3x minus 17 that we just got, and I'm plugging in 0 for h of x and solving for x to find the x-intercept. So 17 equals 3x, and so x equals 17 thirds. All right, part C, sketch the boundaries of the parallelogram on the graph. So looking back at the original problem, it says it's bounded by the x-axis. So here's my x-axis. I've got a line here. And then it's bounded by the line g of x equals 2. Since there's no x on that, that's just like y equals 2. That is the line y equals 2. And so I can put that one up here at y equals 2. That's g of x. And then this is the x-axis. And then the line f of x equals 3x. So the y-intercept for f of x is at 0. And then it has a slope of 3. Now I could just say f of x equals 3x. I want to know when that equals 2 so I know where it intersects this line up here. But actually that's not going to really help us, but you could do it. So x equals 2 thirds. So it would intersect at 2 thirds, wherever that is. Oops. So this is f of x. And then we also have h of x, which also has a slope of 3, but its x-intercept is at 17 thirds. So I'm just going to put that on my graph. And then it also has a slope of 3, so just make it parallel to the other, to f of x. Okay, there is h of x. All right, so there's your parallelogram. Sketching all 4 of those lines. So now use the area equals base times height to calculate the area of the parallelogram. Okay, so let's think about that. Base times height. So let's get the base of the parallelogram. Well, that's just this distance here from x-intercept to x-intercept. That's why we calculated it. So this is your base. And that's going to be 17/3 minus 0, right? That distance there is 17/3 minus 0, so it's just 17/3. And then what about height? Remember, height of a parallelogram is actually the height perpendicular to the base. So it's going to be this here. So that's h equals 2. So now I can do area equals 17/3 times 2 to figure out the area of the parallelogram. Well, that's going to come out to 34/3. We can also approximate that. 34 over 3, 11.3. Repeating. Well, that equals 11.3 repeating, so I'll change that. And we don't have any units, so that's just the units. All right, so that's the area of the parallelogram. So it's very important if you're talking about geometry or anything like that, you can always sketch a picture, and use that to help you find any equations or whatever you're trying to calculate. All right, that's it for 4.2.